Welcome to Programming Fluency. This is section 4.1, Defining and Calling Functions. Until now, every line of code you wrote lived inside main. In this video, you learn how to break your code into named, reusable pieces called functions. Let's begin. So far, every program you have written lives entirely inside main. Now you will learn how to define your own function, call it, and watch how control flows in and back out. Let's get started. This is the plan for this video. First, we ask why we even need functions. The answer is that they let you break your code into named, reusable pieces, instead of copying and pasting the same lines over and over. Next, you learn how to define a function. You will see its anatomy. That means the return type, the name, the parameters, and the body. Then we look at calling a function and following the control flow. You will see how a call hands control over to the function, and how control comes back when the function is done. After that, we talk about return types. The type you return has to match what you promised, and we cover the special case called void for functions that return nothing. Finally, you will compose functions. That means one function calling another, and you will learn where to place your definitions in a file. Why do we need functions? So far, every line of your programs lives inside main. If you need to compute something twice, you copy and paste the code. But that does not scale. Duplicated logic means duplicated bugs. Fix one copy and you might forget the other two. A function solves this. A function is a named, reusable block of code. You define it once and you call it from anywhere. The name tells readers what it does. You already call a function every time you write printf. Someone else defined printf, you just call it. Now you will define your own. This is a function named greet. The keyword void before the name means it does not return a value. The void inside the parentheses means it takes no input. Inside main, we call greet, then print a line, then call greet again. The output shows the greeting, then the middle line, then the greeting a second time. The same function, called from two different places. Let's run it. Calling greet twice runs its body twice, with the printf in main sitting in between. The output shows the greeting, then the middle line, then the greeting a second time. The first call to greet prints hello, welcome to the program. Then the printf in main prints let's get started. Then the second call to greet prints the welcome line again. One function, defined once, called from two different places. Three things happened in that program. First, the definition. That is the greet block. It is the code that runs when greet is called. Second, the call. The line greet, open paren, close paren, semicolon, tells the program to run that block. Control jumps into the body, runs the printf, then comes back. Third, reuse. You can call greet as many times as you want. And if you want to change the greeting, you change it in one place, the definition, and every call gets the new message. So what exactly is a function definition? It is a block of code with four parts: a return type, a name, a parameter list, and a body. The return type says what kind of value the function produces, or void if it produces nothing. The parameter list says what inputs the function accepts, or void if it accepts none. The body is the statements that run when the function is called. This is the general shape. Return type, then the function name, then the parameter list in parentheses, then the body in braces. Let's label the four parts on a concrete example. This function takes an integer and returns its square. The return type comes first before the name. Here it is int, so square promises to produce an int. The name is square. It follows the same rules as variable names, and it should describe what the function does. The parameter list is in parentheses. Here it is int n, so the function receives one input, called n, inside the body. And the body is in braces. It holds ordinary C statements. When the function finishes, it uses return to send a value back to the caller. To call a function, you write its name followed by parentheses. If it takes inputs, you put them inside the parentheses. If it returns a value, you can do three things with it. You can store it in a variable, like int result equals square of 5. You can use it directly, like passing square of 10 straight into printf, with no intermediate variable. Or you can use it inside a larger expression, like square of 3 plus square of 4. Each call is independent. Square of 3 returns 9, square of 4 returns 16, and 9 plus 16 is 25. This is one function call, from start to finish. In main, we reach the highlighted line. Int result equals the function call square of x control is about to leave main. Step 1. Control jumps into square. The argument 5 is copied into the parameter in. Step 2. The body of square runs. It computes 5 times 5, which is 25. Step 3. The word return carries the value 25 back, along the green arrow, to the exact call site in main. Step 4. Control resumes in main on the very next line. The call is finished, and 25 now sits where the function call used to be. Let's put a name on that pattern. It is called the calling convention. The steps are as follows. 1. The argument values are computed and copied into the function's parameters. 2. Control transfers to the first statement of the body. 3. The body runs. 4. The return statement transfers control back to the call site. 5. The return value replaces the function call in the caller's expression. And then the caller resumes exactly where it left off, as if the call were a single value all along. Every function declares a return type, the type of value it produces. It is the first word in the definition. The first function returns an int. The return statement sends a value back to the caller. The second function returns a double, a floating point value. Notice the first function has two return statements. A function can have several. The first one reached exits the function immediately. If n is less than 0, it returns minus n, and the second return is never reached. The return type tells the compiler and the reader exactly what kind of value comes back. This is something to watch out for. The return type must match. If you declare int square of int n, then the return statement must produce an int. If you return a double from a function declared as int, the value gets truncated. The fractional part is silently lost. Return 3.9 becomes 3. The compiler warns about a truncated literal if you compile with $wall. But for a double variable or expression, you need the stricter -w conversion flag to be warned. So always make your return value match the declared return type. Not every function produces a value. Some functions just do something. They print output or log a message or update a display. These functions have the return type void, which means returns nothing. Here print separator prints a line of dashes and returns nothing. Print header is also void. It calls print separator twice because functions can call other functions and prints a title between them. One warning: you cannot store a void function's result. Writing in x equals print separator is a compiler error because there is no value to store. A void function returns automatically when execution reaches the closing brace. You do not need an explicit return statement, but you can use one for an early exit. Here, return with no value exits the function immediately. If n is 0 or negative, the function returns right away, and the printf is never reached. This pattern, checking a precondition at the top and returning early, is very common in void functions. It keeps the main logic from being deeply nested. You have seen void inside the parentheses of functions that take no arguments. In C, there is an important difference between void in parentheses and empty parentheses. The first form, with void inside, explicitly declares that the function accepts 0 arguments. If you try to pass any, the compiler reports an error. The second form, empty parentheses, has a checkered history. It historically meant the parameter list is unspecified, and the compiler would not check the call. So always write void inside the parentheses for no argument functions. It means exactly one thing, 0 arguments, in every C standard. You have been doing this with main of void since chapter 1. Let us follow the call chain. It starts here. Main makes the function call sum of squares with 3 and 4. Control descends one level. Inside sum of squares, the first call is square of 3. Control descends again into square. It computes 3 times 3 and returns 9. Back in sum of squares, the second call is square of 4. Control descends into square once more. It computes 4 times 4 and returns 16. Now sum of squares adds 9 and 16 and returns 25. Finally, control climbs back up to main, where result receives 25. Each call descended one level, and each return climbed back up. Let's put several functions together. This program converts a temperature from Celsius to Fahrenheit, then classifies the weather. Notice the structure. Main is short. It reads like a high-level description. Convert, then classify. The details of how the conversion works and how the classification works live in their own functions. If you want to change the temperature thresholds, you edit classify, and main does not change. This is the core benefit of functions. They let you think at one level at a time. When you write main, you think about the overall flow. When you write to Fahrenheit, you think about the math. Each function has one job. One more rule about ordering. The C compiler reads your file top to bottom, and it must see a function's definition before the first call. In this example, main calls square, but square is defined below. The compiler reaches the call, has not seen square yet, and reports an error. It does not know what square is, what it returns, or what arguments it takes. The simplest fix is to define all your helper functions above main, so the compiler has seen them first. That is what all our examples have done. There is a more flexible option, function prototypes, and you will learn about those in the next section. Let's finish with a common mistake: forgetting return in a function that is supposed to return a value. In this code, square computes result but never returns it. C does not automatically return the last computed value. Without an explicit return statement, the function ends, and the return value is garbage, whatever happened to be in that memory location. This is undefined behavior. The program might appear to work sometimes and fail randomly other times. The fix is simple. Always include a return statement in a non-void function, and compile with -wall. The compiler warns, control reaches end of non-void function, catching the bug before you ever run the program. Let's recap. A function is a named, reusable block of code with a return type, a name, a parameter list, and a body. You define it once and call it from anywhere. You define helper functions above main, and you call them by name with parentheses. The return type declares the value the function produces, and the return statement sends it back. Void means the function returns nothing. It is called for its side effects like printing. A call transfers control into the body, then back to the call site, where the caller resumes exactly where it left off. Functions can call other functions, letting you build programs from small, focused pieces. And remember two habits. Always write void inside the parentheses for no argument functions, and always include a return and a non-void function. Next, these functions used parameters, like square of int n, but how does passing actually work? Does the function get the variable itself, or a copy? In the next section, you will learn about parameters, pass by value, and function prototypes.